All right, you guys, what have we been talking about for the last 17 years? Confidence intervals. We started with 1 proportion Z interval. Then we went to 1 mean T interval. And then we just finished with 2 proportion Z interval. And now, guess what?
T interval.
We are now going to look at a confidence interval for a difference of means. Here we go. Let's say, ladies and gentlemen, that we have an SRS of size N1 from population 1 with a mean of mu1 and a standard deviation of sigma 1. And then we have a independent SRS of size N2 from population 2 with a mean of mu2 and a standard deviation of sigma 2. The sampling distribution of x bar 1 minus x bar 2 has the following properties. So let me make sure that you guys all understand what's happening. We have a population that has its own mean and standard deviation. We have a second population that has its own mean and standard deviation. And we are combining them by taking a sample out of the first population, a sample out of the second population, and looking at how different they are. Are you with me? Okay. What is the center of this distribution? The mean of x bar 1 minus x bar 2 is simply the mean of population 1 minus the mean of population 2. Well, that's really easy if you know the mean of population 1 and the mean of population 2. What if we don't know the mean of population 1 or population 2, which we normally don't know?
We have to figure it out.
We have to estimate it using a sample x bar. So then that would become x bar 1 minus x bar 2. We would just take the difference of their sample means, okay? The spread, the standard deviation. Now, if you remember back in the last chapter, the standard deviation for a single mean sampling distribution was sigma over the square root of n. But here's what we need to do. We need to take this from the first population and combine it with the second population. Do you guys remember what is special when you combine standard deviations? Can you just add or subtract them? No. You have to square them first, then add them together. This is why this is not a good idea. You have to square them first, then add them together, then take their square roots. So, here is the standard deviation of x bar 1 minus x bar 2. We're going to take the standard deviation of the first population squared over n. I want you to know that what that is this formula, sigma over the square root of n, that is this formula squared. Sigma is squared, and the square root of n is squared, and therefore it's just n, okay? Then I need to add the standard deviation of the second population squared over the second population sample size. Again, that is just the second population standard deviation squared over the second population's square root of n squared, which is just n. Once you add them together, yes, you are adding because we're never going to subtract here. What do? We take the big square root of all of that. That's how that formula comes to be. And that is the standard deviation of a combined standard sampling distribution of x bar 1 minus x bar 2. Yes?
So why doesn't the big square root just cancel out the square root of the standard deviation?
So that's it. Basically takes it off of the bottom. But when I square the standard deviation here, so I square this standard deviation, and then I divide by the square of this. So the square root of n squared is just n. And so I can't cancel out these squares here because I have to combine these first. And if I canceled those out, then it's not mathematically equivalent. Yeah, I have to do what's under the square root first. Okay? All right, so there's our standard deviation. Everybody good?
Yep.
Perfect. What is the shape of the sampling distribution of x bar 1 minus x bar 2? What do you guys think it's going to be?
Normal.
It's probably going to be approximately normal. All right, but there are some ifs here. It is normal if one of these apply. All right, do you guys remember how to check the normal condition for means? Okay, one of them could be that n is greater than or equal to 30. What's another one? The population is approximately normal in the problem, okay? And then we learned last time that there was actually that third way. Right, if we looked at the box plot of the sample data, right? Okay, so here we go. Population 1 or population 2 is approximately normal. Not necessarily. So I'm going to talk to you after we write all these down. I'll tell you how it has to work. So it could be that one of the populations or both of the populations, or maybe neither, could be that the population is approximately normal. It could be that N1 is greater than or equal to 30, or N2 is greater than or equal to 30. So the CLT applies. Does everybody remember what CLT stands for?
Central limit theorem.
Central limit theorem. Okay. Or it could be that the graph of sample 1 or graph of sample 2 shows, what are we trying to or hoping not to see on those graphs? No outliers, none at all. Or what else can't we see?
Skewness.
What kind of skewness? Strong skewness.
We only have to apply one of these.
Yep. Yep. Or strong skewness. So the T procedures apply. Okay, so here is how this works. It can be any combination of these. Here's what I mean. When you read the problem, maybe it tells you that population 1 is approximately normal, but population 2 is right skewed. So that qualifies population 1. That one is good, and we have halfway to an approximately normal combined distribution. As you continue reading the problem, you see that out of the second population, you took a sample size of 50. So now we're qualified for the second population with this, the central limit theorem. It is totally fine that it is two different qualifications, okay? Maybe your sample size is small in that second population, so you have to look at the graph of that second sample. Okay, fine. It can be these two together. Or maybe both of the populations are approximately normal. Yes, that's when you really celebrate because you don't have to worry about anything else. And so both of these are true. Or it could be both of these, or it could be both of these. It can be any combination. Each population has to meet the normal condition by itself. Does that make sense? Okay? Each population can meet any one of the normal conditions. And they can be different. It does not have to be that they are both greater than 30. If one of them has a greater than 30 and the other one has a good sample graph, great. That works. It can be any combination. Cool? Yes. You not really. Not for 2. You'll see why. You'll see why soon. All right.
You're still dating that, right?
Cool. Yes. All right. So, who is taller? You ready? The distribution of heights of U.S. adult males follows a normal distribution with a mean of 69.3 inches and a standard deviation of 2.94 inches. For adult females, the distribution of heights follows a normal distribution with a mean of, I need you to change this number for me, 65.8, not 63.8, please. Females, normal distribution, mean of 65.8 inches and a standard deviation of 2.8 inches. Suppose that a researcher selects an SRS of 30 males and an SRS of 50 females. Okay? We're going to let X bar M minus X bar F be the difference in the sample mean heights between the sample of males and the sample of females. Y'all got it? We've got a distribution of males. It's approximately normal with a mean and a standard deviation. We've got a distribution of females. Approximately normal with a mean and a standard deviation. We're going to combine to find the difference in their average heights. Got it? What is the shape of the distribution of X bar M minus X bar F? Why is it approximately normal?
SRS of 30, SRS of 50.
Not, well,
Central limit theorem.
actually, you know what? It would qualify for central limit theorem as well.
Boom.
But what else does it say?
Says it in the
All right. Now, what does it say in the problem?
follows a normal distribution.
Adult males are
It tells you that it follows.
That what follows a normal distribution?
Males.
Yeah, you got the black plague now, but it's so shit and
Okay.
Distribution of heights of males.
So,
plague.
both population distributions
Black plague. That is so bad.
both population distributions are approximately normal. So, the sampling distribution of X bar M minus X bar F, which is when I combine them, is approximately normal. So I just want you guys to make sure that you are very clear. This problem did not tell you that the sampling distribution was normal. The problem told you that each population was normal, and therefore when I combine them, it is still normal. The sampling distribution is normal. Okay.
When we get the
What's
numbers
X
for
bar mean?
mean, it's always going to be like written as population distribution, not like mean distribution, right?
Yeah. All right, we need to find now the mean of the X bar M minus X bar F distribution. So we're going to take the mean for the men and subtract the mean for the females. And this was given to us in the problem. We do know the population values here. What is the mean for the males?
69.3.
Okay, and what is the mean for the females?
65.
Very good. And so what is their average difference in their heights? 3.5 inches. So that is the average difference between men and females' heights. And now we're going to check the standard deviation out. The standard deviation of X bar M minus X bar F is the square root of the standard deviation of the men squared over the sample size for the men plus the standard deviation of the females squared divided by the sample size for the females. What?
I swear it wasn't.
Alrighty, so let's plug in and then solve. What is the standard deviation for the male distribution? 2.94. We're going to square that. And what was the sample size from the male distribution? 30. Then we're going to combine that with, what is the standard deviation for the female distribution? 2.8. We're going to square that. And what was the sample size from the female distribution? 50. All right. This is where now you just need the assistance of human calculator. So, Cole, can you please tell us what that equals?
Yeah, it was about 18.2.
Oh, really? Okay, cool. Can someone help him out? Because it's sure not 18.2.
0.667.
My second guess.
You are just a little bit off.
I think their calculator was wrong.
Did anyone else get 0.667? All right, perfect. Very good, very good, very good.
Y'all have calculators?
Yeah, mean standard deviation.
Mm-hmm.
Is that only thing?
When we're working with means, there's always going to be units. So if you remember them,
Okay.
yes. If you don't, it's not going to end your career.
That's double the old
No,
one.
no, no, but like.
All right, now,
Some damn old.
next thing, I want to see if the last 24 hours you have learned anything from that stat chat from yesterday.
Zero thing.
Let's just see here. What is the probability that the females in the sample have a higher average than the males in the sample? Does anybody have any idea how we might figure this
You gotta
out?
use normal CDF for all the things that you have.
Okay.
But I don't remember why that worked.
We know that we have a distribution of x bar m minus x bar f that is approximately normal. We know that because of part A. What is the average difference in the heights? 3.5. And what is the standard deviation of the difference?
667.
All right. So, what now?
Wasn't it
Just put a lower, put a higher.
X bar?
Buddy, use the damn Lakeinator to solve that.
Okay.
It can go
So,
all the way to 50.
okay, good. So what are we actually looking for
You're
here?
looking for all women that are above.
X bar M minus.
Yeah, all the women that are above 69.5.
Perfect. All right, you guys, that is exactly right. We are looking for the probability that x bar m minus x bar f is less than 0. How did you know that it was less than 0?
Because the mean is positive, meaning that
Good.
that's gonna be.
We are trying to, perfect, that's absolutely right, Gabby. We are trying to see this, that the mean of the females is bigger than the mean for the males. Now, why did I put the males on the left side in that inequality right there?
Because it's less than.
It's gotta be still. I still don't understand.
Because that's the point of the question.
Because the men were listed first in the equation for this distribution, okay? And if I flipped this, it would flip my subtraction, which would completely change my question, okay? You have to keep them in the same order no matter what. X bar M is the average for the males. X bar F is the average for the females.
What's the female mean?
Huh?
What's the female mean? Okay, but
This is the average height of 50 females selected from their population. I don't know it.
and how do we solve the problem?
Eat yourselves.
Because I just want to know what's the probability that the average of the 50 females that are selected is bigger than the average of the 30 males that are selected.
So would that mean you take the mean of the females and
That's why I
like it
chose
over your
No, I'm literally going to use that 0 right there and put it on this graph. Okay?
You
Now,
always use 0.
0.
Like you always use 0.
It does seem like it, doesn't it? Now wait, calm down for a second, 2
No,
seconds.
we go left.
Brother, oh
That's
my
what I
God,
don't
it's like
understand.
paint didn't
Buddy,
happen
you
years
damn
ago.
late.
Yep, it's because I'm looking to see that the
I think this guy just
that the
puffed into
female average is higher than the male average. And so when I subtract this over here, that means that x bar m minus x bar f is less than 0. So that's how I knew that it was less than 0. Okay? All right, now let's be careful for a second. Think about this for just a second, y'all. 3.5 is the mean. Standard deviation is 0.667. How many standard deviations down do I have to go to get to 0?
Too many, like way too many. For it to matter.
More than 3, more than 4.
Like too many.
Like, it's about 5-ish, 5, 6-ish, right? 7. So, is this going to be a big number?
Be real small.
This is going to be really small,
Like
okay?
10 to the negative.
So let's just see what we get. Normal CDF. What is the lower boundary of this region?
Forever.
Negative infinity. What is the upper boundary?
0.
What is the mean of the x bar m minus x bar f distribution?
Corey, you up or down?
And what is the standard deviation of the x bar m minus x bar f distribution? All right, you guys. You should be getting a very small number because 0 is very far away from the mean.
I can't even comprehend that many zeros.
Yeah, what he said.
Huh?
Why is it less than 0?
Dude, I genuinely, like, this is so brain negative.
And those of you who say that the answer is 7.7,
You're wrong.
we should probably talk because that would be very, very bad.
Do you have a Band-Aid?
What do you see? I actually don't. What do you see to the far right of that 7.7? E to the
-8.
-8. You guys, what is that number?
It's scientific notation.
Point some shit.
Doing scientific notation.
Now, I know you guys did not hear Aaron about 10 minutes ago, but over here, Aaron said, this is not ever going to happen. Well, he's kind of right. This is probably never going to happen because the probability that this happens is very low. But what is this that we just found?
That's how I feel.
Here's what we just found, you guys. We just found the probability that I go to the female population and I select 50 women and I get their average height. And I go to the male population and I get a sample of 30 men and I get their average height. This is the probability that the average height for those 50 women is bigger than the average height of those 30 men.
That's so specific.
That's what this is. I just said that this is the probability. This is the probability that an average of 50 women compared to an average of 30 men, I average their heights. This is the probability that the average height for the women is more than the average height for the men. It's not going to happen. Not with these two populations. Very good. All right, you guys. Now, confidence interval for the difference.
Well, we gotta be pretty confident on that. If we're like,
You ready?
this is the exact number.
I can't.
This is your fourth inference procedure. It is a 2 mean. Anybody know? 2 mean t interval.
You gotta be pretty freaking sure.
Anybody want to guess what the 3 conditions are?
Oh, the normal, independent, random.
Random, independent, and normal. Are you tired of this stuff yet?
Slaky.
Colin.
Can I just write 10% for Norton?
Sure. Normal or random SRS of N1 from population 1. SRS of N2 from population 2.
And at least what, huh?
10 times N1 has to be less than the population size of 1. 10 times N2 has to be less than the population of 2.
Let me tell you what, that great.
Now look,
You ever heard of
the normal condition. Do you guys remember what we talked about at the beginning of class where it could be any one of the 3 and it could be each one different, blah, blah, blah. Population is approximately normal and it's greater than or equal to 30, or the sample data has no outliers or no strong skewness, and it can be any combination of the 3 things, right? Yeah? Do you want to rewrite all that?
Hell no.
Yeah, neither do I. So, see first page.
Do you have any?
Now, let's look at all the formulas. Because we don't know the parameters. We're going to replace the standard deviation with the samples. So, what is going to be the results? We're going to have the standard, what? Error. Ladies and gentlemen, if you look at your formula chart, On the back side, halfway down, you will see the standard error formula for x bar 1 minus x bar 2. And it is this.
Stop.
It is the square root of. Now, I don't know the standard deviation of the actual population, so I'm going to have to use the standard deviation of the sample. And I'm going to square it, and then the sample size. And then I'm going to have to use the standard deviation of the second sample, square it, and then the sample size.
Was it that deep? You just put it?
That's the standard error.
This is like the same thing as like the last.
It's the same formula, it's just using the standard deviation of the sample instead of the standard deviation of the population because we don't know that value.
Just sad to put your
It's S sub x instead of the sigma. The sigma. Yep. All right, and then the formula for a confidence interval for a difference of means. Here it is. X bar 1 minus x bar 2. This is the point estimate. Have a great day. This is the point estimate. Plus or minus. What's going to come next?
Margin there.
The margin of error, yes. But what are the little parts of the margin of error?
Intervals.
The T-star critical value.
I'd rather just wait intervals.
And then, what comes next?
Yeah, that was my best guess.
What's the other part of the margin of error?
Killed Stonewall Jackson.
It's the standard error, which is what you just wrote down.
That was so good, man. That man up there in property leaving.
That's your standard error, which we just wrote down 30 seconds ago. And as Colin so eloquently told us, when we multiply these two values together, that is the margin of error.
Good job, Colin.
Okay?
Or intervals.
This is how the interval is created. Now, ladies and gentlemen, doesn't that look like a bunch of... No. You don't want to do this, do you?
I do not want to do
Yeah,
that.
guess what? You're not going to.
Thank you.
But that's the format that we're using. Same format we've been using for 72 years.
72.
Yeah, well, all right. Now, here's the kicker. We're going to use a T-star critical value with the C% confident, blah, blah, negative T-star, positive T-star. It's the same stuff we've been doing, la-di-da-di-da. But do you guys remember back when we did one sample means and we had to get degrees of freedom? And we had to do n minus 1, sample size minus 1?
Yeah.
Do you remember that?
Yeah.
N minus 1? Well, when we go from one population to two, the degrees of freedom go from n minus 1 to this. This is how you calculate the degrees of freedom when you have two samples.
Oh my.
I do like the term degrees of freedom.
Isn't that nice?
It is quite patriotic.
So here's what we're going to do, ladies and gentlemen. We're not ever going to look at that formula again. And we're going to use the degrees of freedom that our calculator gives to us. Okay? Is that fair? Perfect. Now there's one more thing I need to explain to you guys about how your calculator is going to do this. So in order to do that, I need you guys to go to Stat, Test, and I need you to find the 2 mean t interval. Stat, Test, find the 2 mean t interval. Tell me when you find it.
I need batteries for my calculator. I have them at home though.
Okay.
2.
2 mean t interval. Everybody see it?
2.
All right, so obviously you know you're going to stay away from anything that says prop, right? Because that's proportions, and that would be wrong.
2.
You're going to not do anything that says test, because we haven't learned how to do a significance test yet. We're doing all intervals right now. And so our calculator is kind of weird. It doesn't like the word mean. It prefers the word samp for sample. So you're looking for a 2 sample t interval. 2 sample t interval. Very good. Everybody go to stat test 0. Stat test 0. It is a 2 sample t interval. You will see that you have a couple of options. You either have individual data in your calculator or you have stats that would be given to you in the problem. But here's what I want you guys to do. Whichever one you're on, it doesn't matter right now. But I want you to scroll down. Do you see where it says pooled? Do you guys see pooled? For now, anytime you see pooled, you're going to say no. All right? From now on, until I tell you otherwise, if you see pooled, say no until we learn what that means later. Cool?
Buddy,
Yeah, we'll do all those later.
using hands gotta get you.
Mm-hmm.
Buddy.
All right, so here's what we're going to do. I want you guys to skip the next page because that is a full state plan do conclude, and obviously that ain't happening in 9 minutes. But I want you to go to the back side of your paper, or the last page, sorry, the last page, which has this example on it.
I don't want it.
And here we go. The National Assessment of Educational Progress, a Young Adult Literacy Assessment Survey, blah, 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 interviewed a random sample of 1,917 people, 21 to 25 years old. The sample contained 840 men and 1,077 women. The mean and standard deviation of scores on the NAEP's test of quantitative skills were X bar 1 equals 272.4 and S sub X1 equals 59.2 for the men. So there's the men's data in the sample. For the women, the results were X bar 2 equals 274.73 and S sub X2 equals 57.2. Which of the following gives the 90% confidence interval for the difference in the mean score for the male and female, male versus minus female? Ladies and gentlemen, all you have to do for this problem is plug it in your calculator.
Oh my, easy.
So, go to Stat Test 0. You're probably already there.
Chip still misses.
Now, do you have data or do you have stats?
Stats.
You have stats here, okay? And you're literally just filling in all the information.
Not bad. Watch him get this perfectly correct first try.
This is under Stat Test 0.
Just so you know, if you get this wrong, Biden gets 100,000 votes. You get this question wrong.
Oh, buddy, I'm sure we already made up 200,000
What's
already.
Huh?
I know everyone's saying.
Damn, bad.
N1 is the sample, so what's the sample size for the men?
Oh, it's it.
Okay, you're just plugging in everything into your calculator. Again, make sure that when you say pooled,
Made up.
you're going to say no. We do not go swimming in the pool at school.
Back in 2018, how much she voted for you?
Exactly. What he said.
You got both booths up in heaven.
Wait, cool, no.
Pooled is no. Now, when you guys hit calculate, you truly need to be patient. Your calculator does take a couple of seconds to get this answer because it's doing a lot of work. It's got to calculate that degree of freedom. That'll take you 20 minutes just by yourself. Okay?
20 minutes.
Nah, maybe not that long. All right. Now, please tell me what is the low estimate for the difference of these means?
Negative 6.619.
What is the high estimate for this difference in means?
2.08.
Looks like you've saved this country.
Now, ladies and gentlemen, time out. That's the answer. If you got that answer, you got it right. Now, look at the multiple choice questions or options. Which one is closest to the answer we got?
Definitely B. Definitely B. It's only 0.7 away on the second one. It's only
Definitely A. It's
0.04
definitely A.
away.
It's
Yeah.
definitely A. It's literally point.
Yeah, it's B.
No, it has to be B.
It's A. Bro. Crap.
B is the
Yep,
closest.
you failed.
Oh, I admit.
Now, I want you to know
So many voters.
that was an accident. Okay? I didn't mean to not give you the exact answer. That was an accident. But that's how you do that. Tomorrow, we will state plan do conclude with data.
This country plunges into mayhem.